Okay, this video is going to go through how to interpret a scatter plot. So now that you've learned how to draw them by hand and how to do them in Excel, now you need to have a look at some of the basics of interpreting what a scatter plot is telling you. So over here I've got a couple of different simple scatter plots. So what we need to look for is a pattern, and it needs to be a really clear pattern. This very first one, no pattern. Therefore, there is no association. There's no relationship, nothing. So those variables have nothing, no association or relationship between them. This next one here, we can see a clear pattern. What we see is all of these dots in the scatter plot. As x increases along there, all of these dots are getting higher. So what we're basically seeing is as x increases, so as we go along here, as we get along this way, these dots are going up. So that means y is increasing. This next one, also clear pattern that we can see. As x increases, so as we go along the y-axis here, the dots are going down the y-axis. So as x increases, y decreases. Now we call this an inverse relationship. As one goes up, the other goes down. This last one, there's also a clear pattern. It's a non-linear kind of pattern, but we do actually have one. So as x increases, so as we go along that x-axis, y increases, then y decreases. So it only increases to a point, and then y will decrease. But we can see those clear patterns, and in this first one, no pattern, no association. So what do we look for when we are looking at interpreting a scatter plot? We will look for three things. We look for direction, form, and strength. So let's have a look at direction first. So this is the direction of association. Now what I'm going to do is give you the few different ones. So if there's no association, then there's no direction. So no association, no pattern, we go no further. But if there is a positive association, this means that your response variable increases as your your explanatory variable also increases. Now which one would that be? That would be this one. So as x increases, so does, your RV, so your response on your y, your dependent, increases as EV increases. So as we go along here, these increase. So this one here is a positive association. Then if we have a negative association, that's when our RV or our response variable decreases as our explanatory variable increases. So that would be this one here. As our explanatory variable increases down here, our response variable is decreasing. So as we go along, they're going down. So this one is negative. It's a negative association. Now what I can do is just draw up. We're going to do just a little one here, where if I say dose in milligrams, and on this side I say reaction time in minutes, and then I pop in my data points. Okay, when I look at this, I can say that this is a negative association, And what I can say is that as the dosage increases, reaction time decreases. So as I increase the dose, the corresponding dots here along the y are dropping down the y-axis. It's a negative association, and I can say as the dose increases, the reaction time decreases. Or I can say reaction time decreases as the dose is increased. Now, until I have to actually explain this, I don't actually need to know what they are. So if I'm just interpreting the graph, it doesn't matter what dose refers to or what reaction time refers to. As long as there are headings there, I can describe it. Okay, so the next thing we look for is form. Now, there are a couple of different types of form. Oh, that's not good. Ugh, let's pick a different colour. Now, form. Let's go over here. We've got, like this, we've got time in seconds, and this way, velocity, and that's measured in meters per second. So, then I put my dots in. And what I can see very clearly is I can actually put in a linear trend line, just like I showed you in graphing in Excel when you graph scatter plots. So a linear trend line means that graph has a linear form. So this is linear. Now I can also have one that's linear that is negative. So they go down like this, but as you can see, the dots are really clustered around a straight line. So the dots themselves, if we join them together, don't make a straight line. We don't join together scatter plots. What we do is we look at where the data is sitting and we go, look at that, I could put a line with around the same number of data points above and below that line, and it's a straight line. So this one here, not only is it linear, but it's also positive. This one down here, oh, I actually did that round the wrong way, didn't I? This one down here could be linear and negative. So again, linear straight down, but a negative association. Either way, linear means that there's a straight line through the data points. The last one though is non-linear. So non-linear looks like this. Let's draw one down here. So basically I'm going to go with time spent practicing, practice time, and performance level. Now if I were to then dot in my data points, what I would find is that I could still draw a trend line in, but it's not straight. So basically I could go like this, where I can see it increases, and then it kind of peters out like that. So I get this lovely curve going. It's a non-linear form. What this basically means is that in general and at first, the more you practice, so as I increase the time I spend practicing, my performance level also increases. But it doesn't do it in a proportional way like linear. Linear, however much you go along this line, it goes up by the same amount. That's what makes it linear. This one though is the more time I spend practicing, my performance level at first will increase, but then slowly it will increase less and less and less until I get to a point where it just stays at the same level. That makes sense because you can only there are mechanics of your body that can stop you from performing any better than at your very, very best, no matter how much time you spend practicing. Okay, so the last thing that we look for, so we've done direction, form, and strength. That's what we look for last, so I do apologise for all the bells in this video. Now, strength looks it's fairly easy to sort of show you. Okay, so, strength. This here, and of course it can be positive or negative. This here is a strong positive. So it's positive because as x increases, y increases, but it's strong because see how close together all those data points are. So in that scatter plot, the closer together they are, the stronger the association. So I could also have a strong negative, and it would look like this. Again, strong association because the data points are so close together. Negative because of the direction. Yep. Okay, but what I can also do, and again it could be negative or positive, is I can have a moderate. Now a moderate is where they're kind of spaced out. You know, they're not as close as strong. So this one is moderate. Make sure yours isn't as squished in as mine here, I just run out of room. And again, it can be positive or negative, that makes no difference. But see how they're more spaced out, but we can still see that pattern. We can still see a clear pattern. The last one though is the most unreliable of all of them. So when I draw this one, this is our weak association. And basically, it's because the data points are really quite spread out. Not quite enough to say that there's no association. So you can still see a really general trend for as x increases, y increases, but it's just a general trend. It's very different to this strong association. It is a lot weaker over here. Now basically this video has gone through some of the language for you to be able to look at a scatter plot and do some of the basic interpretation using the correct language. This will then actually help you in a bigger investigation like your PSMT, be able to use the right language when you're trying to describe all of your different variables and what it all means. Make sure that you've copied down all the examples, less squished in than mine here.